Good morning. So today what I'd like to do is just go through some of the menus on your Siemens Singo system. This happens to be VA25. It's older software. These will be the same in A series software, B, C, D, E. They're all the same. Beauty part about Singo is that they didn't change much. But most of the questions I get and most of the calls I get is, about software are, how do I get the serial number and my options? So to get the serial number of the system and to find out what software you're running, if you're at the exam card, you can hit help and then you can go to info, and that'll bring up this general tab here, and they're pretty much the same on all the software series, so there's no difference whether you're running B, C, D, or E software. But first, it'll tell us what the system is. This happens to be a Symphony. It gives us the system serial number, 22758, and then the software type, and then the version. So Numeris, everybody, what's Numeris? It's Nuclear Magnetic Resonance Imaging System version 4. So version 4 is the newer style of Singo compared to the old 3.5 system. The old 3.5 system ran on a Unix shell. It was black and white, and the exam card looked very different. Version 4 is this iteration of software. The software packages are shown below that. These are the service packs and or patches that have been added to the system, and then this is where the product is licensed to. If we click on the next tab, this is the system tab. It'll say main console. You don't see what's called satellite consoles too frequently in imaging centers, which this system happens to be in. The satellite console is usually in bigger hospital settings. The satellite console is usually in hospital situations, in hospital scenarios, where the technician, when they're done scanning a certain protocol, that protocol images are instantly populated onto an additional console called a satellite. What that allows the hospital to do is run your composing task, your MIPS, any post-processing that you want to do while the system is scanning. Therefore, you don't stop. That way, the technician who is scanning can just scan, and then another technician can do those post-processing tasks. Under your hardware options, here you can see your CD-ROMs and your DICOM printers and your hard copy printers. The big thing to take away from here is the gradients, quantum gradients. So Symphonies that are non-TIM systems have two styles of gradients. There's quantum gradients and then what's called Papillion gradients. Papillion gradients come in two flavors. You have three amplifiers, X, Y, and Z. They'll have a 400 volt option for X, Y, and Z. If you have the Papillion 800 volt gradients, you'll have two 400 volt gradients for each axis. So 2X, 2Y, and 2Z. It's not an additional cabinet. They're very thin. You'll just have an additional 3 amplifiers inside of the cabinet. The other things are the coils. Don't worry about this too much, because if, let's say for instance, you don't see breast coil here, but if the customer has a breast coil, you can use the breast coil, but these are coils that would be input into the software. So these are the coils that you're allowed to run customer QA on. And then below that, the big one is the software options. So here you see work list, 3D SSD, 3D MIP, angio package, these type of things, care bolus, echo planar, EPI imaging. This being an older Symphony non-TIM, this is pretty much what you're going to see on most of them. You're not going to see Blade or Twist or Twix or anything like that. And then here's the version of it, and then the expiry days. So if you could see here, we've got 3,650,000 days left. That's just a generic number that Siemens uses to determine that this is infinite. It does not expire. And if we go to our next tab, disk database, all this really is going to tell you that what your free space is on each drive. Not a lot of people use it. This is your local and exchange board. If you don't know what the exchange board is, the exchange board on a Siemens unit is a logical database that the system uses to transfer to DICOM nodes. So what it'll do is it'll scan, it'll acquire, it'll create the protocol images, it'll send it to the exchange board, and then the system is freed up to keep scanning, and then the exchange board will send it off to a network node. That's really all that does. Sometimes it gets corrupted and you have to delete it and restore it. These are the network types. So this would be the host name or the node name. This would be the AE title, and this would be the IP address. This is a good indication of what is installed on the system. So we click OK. One other menu that your service provider or yourself might utilize that is good to have in the back of your pocket to know where it is under System and then Control. So when we go to System Control, the first thing is that the first menu that's going to show up is the Host tab. And this is our System Manager. So you can see under Exam Task, Viewing Task, Filming Task, 3D Task, and Dynamic Analysis Task all have green arrows pointing up. The rest of them have red arrows pointing down. And you're like, wow, something's not running. Well, if you look, we have Exam, Viewing, Filming, and 3D. So these tasks are already running. Well, we also know that they have the Argus task. So let's say mean curve. So if we say, oh, well, we want to start mean curve. Well, we can't. We don't have that option. But do they have any of them available to them? Anyway, if they did have that, we could click on the Argus and then hit Start Application, and it would show up down here. The next tab over is the Image Reconstruction System. This is a visual representation of the system's imager. What the imager does is it takes raw data from the receivers, turns it into an FFT, and then turns the FFT into an image, and then sends it via an Ethernet cable to the host file for display. So all of these need to be running. Iceman is Image Calculation Manager. That's the main one, but all these need to be running. And if you look, if there was an issue, we can restart the image calculation and restart the periphery server. That will just start the tasks running on the top of the Windows shell. So you will get a red arrow down, then you will get an undefined blue arrow. You will get a red arrow down as they're restarting, and then a green arrow up as they're running. If that doesn't work, when you see IRS control or Image Reconstruction System control, the reboot button will actually restart the physical computer. It will shut down Windows, it will enable it and restart, and then the system will restart and restart Windows. The big one here is the MR scanner. So what are we looking at? This is the status of the entire system right here. So GPA is the gradient power amplifier. What is K2217? That is the model number of the gradient cabinet. So GPA K2217 is quantum gradients. If it said GPA K2209, it would be the Papillion 400s. The TRA1 is the transmitter. The IOP is the input-output processor board. That changes all of the electrical CAN to fiber optic CAN. Fiber optics are everything inside of the magnet room. That way we can talk to it without actually being an electrical signal. It's cleaner, it's faster. RFPA is radio frequency power amplifier, K2204. That's the model number. It's a liquid cooled 15,000 kilowatt amplifier. The RFAS stands for radio frequency acquisition system. That's the entire everything else other than the RFPA. MSU is magnet supervision. RCA is the cooler. It's not the chiller, it's the cooler, the secondary cooler that is chilling this system with distilled water. The RFCI is the radio frequency cabin interface. That's everything in the back cabinet that's talking to the magnet room. So stuff like your coil connectors, the coil itself, the LCCS, the body tune box, the Talus, the BCCS. Patient table, body tune box 1 and body tune box 2. So on older Symphonies, you need a body tune box. What is a body tune box? It actually tunes the patient to a 50 ohm load using capacitors and resistors. Body tune box 1 is for the 0 degrees on the body coil, and body tune box 2 is for the 90 degree. PALI and STIMO. PALI stands for Power Absorption Limiter. This monitors runtime SAR, and I can go over SAR in a minute. And STIMO is stimulation. That monitors runtime stimulation from the gradients, whether they're turning on and off fast enough to actually create stimulation inside of the patient. So, PALI absorption limiter. Let's talk about that for a second. Power absorption limiter. So there are two types of SAR, and I'm just going to close this for now. There are two types of SAR. There's look ahead, and then there's runtime. So if I look at my SAR calculation right here, it's saying 45%. Well, there is a head coil with a phantom inside. And I take this T1 spin echo sagittal, and I bring this open and over, and I click open. With the service patient loaded, I happen to know it weighs 100 kilograms. But if I go here to SAR information, it's going to show me the displayed values being to the current patient. Okay, so what's SAR? Specific, so PALI, power absorption limiter. The power absorption limiter measures runtime SAR. What is runtime SAR? Well, there's two types. There's look ahead, and then there's runtime. So if I look down here at my SAR calculation box, and what is SAR? SAR is specific absorption rate. Specific to what? Specific to the patient. So weight, age, male or female, that type of thing. Each patient has a specific absorption rate. Well, in MR, there's no ionizing radiation, but what does the RFPA do to flip the proton? It creates heat. What does heat do? Well, if you can't radiate heat fast enough, you'll start to overheat, you'll start to sweat, there could be problems. You know, if you're an older person, too much heat, you might get a stroke, things like that. So there are issues for safety for SAR. So right now, this T1 spin echo sagittal protocol is showing that with this service patient, roughly at 100 pounds, at the head, they're going to get 26.9% of what they can actually take of the exposed amount of RF. So, exposed body will get 44.6%, and the whole body will get 1.8% of the total amount of SAR it can actually handle. And what does that mean? How much heat can it dissipate over a given time? So, we know we're doing a head, and we know we're going to get almost 27% of what it can take. And then here's something interesting: exposed body. What does that mean? A lot of people think, oh, I'm getting SAR errors, I'm doing a head. Yes, you're flipping the protons in the head, but you're also flipping the protons in everything inside of the imaging volume. So everything inside of the magnet is going to get 45% roughly of what it can take, but the head is going to take 26% of what it can take. Average that off over the whole body, and you get 1.8% of what it can take. So there's normal mode and first level. So normal mode, the way it was explained to me, is that the system software thinks that the patient has the flu. So what does that mean? Well, what do you have when you have the flu? You have the chills, you have the shakes, you're freezing, but at the same time you're sweating. When you're already sweating, you can't radiate as much heat as you could if you were not sweating. What does the body do when it starts to overheat? It starts to sweat. Why does it sweat? Because the water comes to the surface of the skin, moving air touches it, and it helps the body cool off. Well, when you're already sweating and you're inside an enclosed environment like the MRI, and the patient fan is going, it can only radiate so much heat off of your body. So first level is a way to say the patient isn't sweating, they don't have the flu, and you can give them more SAR. So if I was to click first level, if you are about to switch from normal operating mode to first level controlled operating mode, please pay attention to the warning in the help box and follow the described instructions. So if we click OK, it's going to move everything to first level. And now if we look at the exposed body, it's got 22.3%. So it's roughly half of what it was before. Keep in mind that the head didn't change because the head is in ISO center. But at this point, quote, the patient doesn't have the flu, we can give them more SAR. And all that really means is we can give them more RF. And what does that mean? If there was a certain sequence that if you were to get a SAR warning for, it might say change the flip angle from 127 to 94. And that means it's going to need less RF to go to 127. Now it's going to 94. It might tell you to decrease the amount of slices. It might tell you to increase TR or lower TE. And it might have you add a 30-second pause. I don't actually have a patient in the bore, so I can't simulate that. But one thing to remember is if you're at first level and you're getting SAR problems on a lot of different patients and a lot of different protocols using different coils, etc., you may have a problem with what's called the TALES, the TALES, or the transmit level sensor, or the transmit antenna level sensor. And what the transmit antenna level sensor is doing is it's monitoring the amount of RF coming out of the RFPA through itself for runtime SAR. So as RF is getting transmitted through the RFPA, through the cables, through the TALES into the patient, it's going to monitor the amount coming out of the RFPA, monitoring how much is into itself, comparing the two, make sure that they match, and then transmitting into the patient. If, for instance, that was to get out of control, or they thought the patient was going to have too much, or the RFPA is giving out too much or not enough, and it doesn't match the TALES, you're going to get what's called a runtime SAR error, or a power absorption limiter error. It's usually in the form of too much RF. Generally, if the system doesn't have enough, it'll compensate and kick out more. But that's a service issue. The TALES is supposed to be replaced every 2 years, and it also needs to get tuned up at least once a year, just to verify that the directional coupler in the RFPA and the directional coupler in the TALES match, and that they're giving the correct numbers to each other, saying I'm giving out 10,000 watts. Yes, I'm receiving 10,000 watts. The patient is getting 10,000 watts to flip the proton, etc. So there's that. So if you have any more questions on SAR, just comment below and I'll try to answer them.